So now we're going to draw a picture of what these compounds look like when they dissociate, when they split into their ions. So what is lead going to do when it changes right now it's a solid. When we put it into water, what are the particles going to be? Lead and nitrate. So lead will be aqueous because it's an ion now, and nitrate will be aqueous because it's an ion now. So I'm going to draw those in there. How many nitrates will I have? 2. So I'm going to draw that in there. Lead, nitrate.
How many PBs are there?
How many are in the name? See, this is why I wanted to use them. No. Lead's going to make 2 nitrates, so you have to have 1 lead for every 2 nitrates. So if you do 2 leads, you have to have 4 nitrates.
Do I have to add the AQ on the end?
Yes, because they're dissolved in water.
How do you know how many to put in there?
Because this says 1 lead, and it has a 2 that means 2 nitrates.
Can we just do 1 lead and 2 nitrates?
Uh-huh.
Why is there... Oh.
Why are we writing more of them?
Because I wanted to.
Oh, okay. So it's like, it's not a required thing, you just have to keep the ratio.
You have to keep the ratio.
Oh.
Okay? The next one, calcium chloride, is going to break down into calcium ions and chloride ions.
Wait, the ratio is 2 NO3 for every P.
Uh-huh.
So I can just do 2 NOs and...
So what effect does the charge have on how many lemons?
Well, when you write a compound, the charge of all the ionic compounds have to add up to 0. So lead here has a +2 charge. We know that because each nitrate is a -1, and we can look that up on the back of our periodic tables. And since there are 2 nitrates, that tells us we have to have a -2 charge. I'm sorry?
So, okay, so then it's P2, right? And then it's N1, you just go P1, N2.
Uh-huh. All right. The next one, sodium sulfate, is going to break into 2 sodium ions for every 1 sulfate ion. So now you're going to have 2 sodiums for every 1 sulfate. And the next one, lithium fluoride, is going to break into lithium ions and fluoride ions.
Is that SO8?
Huh?
SO8? SO4, I think. Sorry.
All right. So I don't really like the wording of this next part, but we'll go with it. Some ionic compounds break into ions when they are dissolved in water. I would argue that all ionic compounds dissociate at least a little bit. But you have a spectrum of solubility, just like we have the electromagnetic spectrum of different types of light. Some things are more soluble than others. So with our solubility chart, we're talking about normal temperatures, room temperatures and pressure and all that. If they have, and there's a K constant, solubility constant, if it's above a certain number, and we're not going to get into all that. If you take AP, you will get into that more. Okay, but some ionic compounds break into ions, but so basically, like I said, I would argue that all do. They will break into ions based on their solubility. When they break apart in water, you can represent them as positive and negatively charged ions. Positively charged ions and negatively charged ions. All right. Factors. Yes.
So, on the examples above, if you had a formula that was insoluble,
Uh-huh.
How would you write that in like the cup thing? Would you just say?
Good question. Let me show you. So, I'm going to plug this in. Maybe. So, if you had something that was insoluble, for instance, trying to think of an example we've used. Huh?
Ni3.
No, because it's a covalent compound. We're going to talk about that in a second.
MG3PO4.
All right, MG3PO4. MG3PO4 2 will not, it will ionize a tiny bit, but for our purposes, it doesn't. So you put it into water, and it's just stays a solid, a clump. Okay, you would probably have to add it to an acid to get it to dissolve. So what it's going to look like when you put it in there, that's NG. Hang on.
Oh, so you're gonna be putting it in as a whole block.
And this is an example of an.
This is an example of insoluble.
Basically together the whole time. Yeah, that's my guess.
So you would just have examples like this. Uh-huh. Good question.
And this is an example of an insoluble
Yeah.
compound staying an insoluble compound.
Yes. All right. Things that affect solubility include temperature, stirring a solution, and the size of the particles. If you've ever made Kool-Aid or lemonade, you know that stirring helps things dissolve faster. If you've ever had hot tea and they asked you if you wanted 1 lump or 2, that refers to sugar. A lump of sugar is a sugar cube. All right, if you put 1 sugar cube into a hot tea and then you put a spoonful of sugar into a different tea, the spoonful will dissolve first because those are more spread out. There's more surface area. So they're smaller sizes. The cube kind of keeps some of the water at bay. It takes a little bit longer for everything to dissolve. Okay? Now, we never split up covalent compounds or acids. All right? And actually, I put an asterisk next to that because there are 6 acids that you can split up. We'll learn when we do acid bases. All right? but we never split up covalent compounds. Only ionic compounds can split up into ions, and you must check the solubility table to find out how soluble they are. Ionic compounds, let's recall from December, are made of metals and nonmetals. For instance, sodium chloride. What does sodium want to do to be happy?
Sodium wants to
away
give
an electron.
He wants to give one electron. Sodium wants to give his one electron away to chlorine. Now, when he does that, he becomes positively charged, and the chlorine is now negatively charged. And that's what holds an ionic compound together. That's why water, because it has a positive end and a negative end, can dissolve ionic compounds. Okay, if the water pull is stronger than the plus minus, it'll dissolve it. If it's not stronger, then it won't dissolve it. Okay? So, which one of these examples will change into, will split? Which of these are going to be examples of ionic compounds? NaCl, lead, nitrate. Let's try and say the names.
Sodium sulfate.
Sodium sulfate.
That's it.
Why not carbon dioxide?
It's the two nonmetals.
It's two nonmetals. Why not water?
Two nonmetals.
And water actually will dissociate a tiny bit, but it's a different story. How about sulfur hexafluoride?
Two nonmetals.
Nonmetals. Sucrose is a nonmetal, and silver is just an element. Okay? Now, why don't covalent compounds? Well, let's draw a picture of covalent compound, and we'll use carbon dioxide. How many electrons, hang on. You remember back in December when you did Lewis structures?
Yeah.
What did we have to do? We had to add up the valence electrons, right?
Right.
How many valence electrons does carbon have? 4. How many does each oxygen have? 6. So we have a total of 12 for 16, right?
Right.
So if we draw a carbon bonded to 2 oxygens, we have, each line represents how many electrons? 2. So we have 4 electrons. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All my electrons have been used. Does my carbon have enough electrons around it?
No.
It needs 2 more. I mean, 4. It needs a total of 4, right?
It needs 4 more. So we're going to move these.
There we go.
Those 2 over. And those 2 over. Okay, and we call that a double bond, right? Okay. Now what's really happening in a bond is that chlorine has an electron in his orbital, and oxygen has an electron that overlaps in his orbital, and so you end up with overlapping electrons. Okay? And that's what a bond is. Is that going to be something that's attracted to water? To a positive and a negative? No. No, there's not any positive or negative part of it. So that's why they don't ionize. Okay. So let's talk now about substances that will break into water. Well, you are in chemistry, Surprise. Okay. CH4. Will that ionize? Will that dissociate in water?
No.
No. So this guy will not dissociate. What kind of reaction is that?
Single replacement. No. It's made of combustion.
It is combustion. Combustion reactions are not ionic. How about the next one? Zinc here is a metal, so he's solid. But silver nitrate, we did a lab where instead of zinc, we used copper, and we added it to silver nitrate solution, right? So silver nitrate is aqueous. And that zinc then will trade places with the silver, giving us silver, and zinc nitrate is still aqueous, right?
Right.
What kind of reaction is that?
Single replacement.
Single replacement reactions are ionic.
No.
Double replacement reactions are ionic. Sodium hydroxide is aqueous. Copper 2 chloride is aqueous. Sodium chloride is aqueous. But the next one, copper 2 hydroxide, we need to look up on the periodic table. Or not on the periodic, yeah, on the back. Okay? Copper 2 hydroxide, what does it tell us about hydroxides here?
Only soluble with group 1A.
And
And
3 other ones. Is copper fall in either of those groups? No. So therefore, copper hydroxide is going to precipitate. Okay, so mark him with an S. What kind of reaction is that? Double replacement. Yeah.
How would you figure out whether or not it was soluble or not based on that one?
How do you figure out whether it's soluble or not? So you go to the solubility table.
Well, right, but like on the equation, like how did you figure out the equation?
On the equation, which one do you mean?
Just like, so we're trying to find like if that equation is like.
Okay, so this first one is sodium hydroxide. So I go to my solubility table. Sodium is group 1A, so they're always soluble.
Yeah.
So he's aqueous. The second one is copper 2 chloride. I go to the solubility table. And copper is always soluble except for lead, mercury, or silver. And copper isn't lead, mercury, or silver, so he is soluble. All right, sodium chloride, sodiums are always soluble. Copper 2 hydroxide, as I just showed you guys, we come down here to hydroxide, and copper is not in group 1A or NH4, and it is not calcium, strontium, or barium. Therefore, he is not soluble, so we put an S. Okay? Does that answer your question?
Yeah.
All right, so now what we're going to do is write out an ionic equation. Come on. Yes.
So, kind of going along with what he said, so would the whole thing be soluble, like when you drew it out in the kind of the jar things?
These two are soluble.
Yes.
And then once you've mixed them, this jar would have NaCl, but down at the bottom you would have COOH2.
Okay, so they don't like relate to each other, kind of. Like they're you don't have to put them together, I guess.
The sodium and chloride? No, they will join up when the water evaporates. Let me show you an example. Come on. Come on. No. Don't move. This is a lab that my College Chem online kids did. You guys are going to do a lab on Monday that is similar to this. You did not do this lab.
No, I said the app.
Okay, here it is. No, you did not use this app.
Oh.
Okay, so if I want to put in, this is a tub of water, and I want to put in, we'll put calcium chloride in. Notice the calcium breaks into one calcium, 2 chlorines, and silver nitrate in. When the silver and the chloride meet up, they fall to the bottom. We can put another silver chloride in and we'll have another one form. So this reaction would have been calcium nitrate plus silver, no, not calcium nitrate, calcium chloride. Plus silver nitrate gives you calcium nitrate plus silver chloride. What fell to the bottom? Do they have charges on them anymore? No. So these guys are now solid. They have settled out. The calcium and the nitrate are still floating around in there. Okay? Does that help? All right. So now what we're going to do is we're going to write an ionic equation. And what we're going to do is we are going to dissociate all of these that will dissociate. So sodium hydroxide is going to dissociate into 2 sodium ions and 2 hydroxide ions. How do I know? Because sodium is always soluble. Copper 2 chloride is going to break down into copper 2 ions, a copper 2 ion.
Is that OH or?
See right here? I just brought it down from there.
So is that 2 connected to the Na and the OH? That's why it's 2 on.
There's a 2 in front of it, so that they're each, that NaOH, there's going to be 2 of them that break into the pieces. This is copper 2 plus 2 chlorines. So that came from there. We're going to make 2 sodium chlorides, which means we'll have 2 sodium ions and 2 chloride ions. And then we've already determined that copper 2 hydroxide will be a solid, yes? So this is what we call a complete ionic equation. Yes?
On the copper, how do you know it's going to be a positive 2 charge?
Because what is the charge on chlorine? Always, always, always. -1. How many chlorines are there? 2.
So,
Because my biggest failure this year was not teaching you naming well enough. All right. Next one, split any compounds, or let's see, first of all, let's do what's aqueous. Is magnesium chloride going to be aqueous?
Yes.
Yes. So silver nitrate is aqueous because we just used this last week. What about silver chloride?
No.
Silver chloride, there are 3 compounds that do not dissolve with that bond with chlorine, and one of them is silver. So silver chloride will be S. Magnesium nitrate will be soluble.
So whether or not they're soluble or not depends on whether or not you break them apart in the equation.
If they can be broken apart, yes. All right. So if we write this out, magnesium plus chloride plus silver plus nitrate those are called complete ionic equations. Otherwise, it's a molecular equation. This here is a molecular equation. This is a complete ionic equation. And we'll talk about net ionic equations on Monday. All right, let's write out the next one. F2 is fluorine gas. At room temperature, fluorine gas is a gas. Iron 3 iodide is going to be soluble because iodide is like chloride at only PMS, silver, lead, or mercury. Fluoride's going to be the same way. And iodine at room temperature is solid. So, let's write a complete ionic equation. F2 plus Fe plus 3 iodines gives us an Fe3 plus 3 fluorines plus the iodine. And we're not going to do that one.
So why would it be 3 fluorines if the iron has a 3 charge?
Because fluorine's -1, and so your charges have to add up to 0. But what? If you look at your periodic table, iron has 2 possible charges, a 2 or a 3. So if you have iron with 2 chlorines, now, let me rewrite it. If you have iron with 2 chlorines, chlorine is always a -1. So iron's going to be a +2. Okay? All right. Let us take a brief break. If you need to go to the bathroom, you can go down to the commons. So the next thing you need to do is put your beginning question in. Which solutions will create a precipitate when reacted together? So you're writing that in your lab notebook. You do not need to do the hypothesis.
I spelled it wrong. I can't spell precipitate.
Gary, I thought you were smart.
Alright. Okay.
Now, in the past, I had them write out all 55 equations in their notebook. You do not have to do that today.
Thank you.
I am going to let you put, these are the equations here. I'll come back. No panic. You're going to just put it into your lab, not in your lab notebook, just in the packet. We'll do them together. Okay? But last year they had to write all 55 out. All right, the next thing is the procedure. We are getting close to having to have a seating chart. Really close. All right, so the procedure is you're going to get a sheet like this, and around the edges are the names of chemicals. This is what it looks like. Only I have little X's or dark spots in mine. All right, so you're going to get a pipette with sodium phosphate, and you're going to put drops of sodium phosphate.
We want to write down procedure, right?
Some kind of fluff just got in my mouth. I don't know. You're writing the word procedure, yes. And you're going to draw the graph, and you're going to put that graph or that chart in your notebook in a minute. And you're going to put each chemical, you'll put drops in each box all the way down.
So just draw all of that.
Yes. So you'll put drops all the way down here. Then you'll put copper 2 sulfate all the way down. And then sodium carbonate. And then the second step will be to find the chemical on the side and go across. And then the third step is to look at it. And you will be looking for a precipitate. Yes, that is an I.
What's an eye?
This is an eye looking.
Oh,
Oh, yeah, I can see it.
Oh yeah.
If you would rather. But to me, that looks like an amoeba.
That looks like first I learned.
I'm sure they're on there.
Once you have finished that, I'll come back to it in a second. You're going to go to the next page in your notes, and you're going to copy this data table into your lab notebook. The data table needs to be big enough that you can write in the box. So do not cram it into a teeny tiny corner. The data table needs to, don't be afraid to use space. The data table you're going to need to be either be writing in VR for no visible reaction or PPT for precipitate. Okay? So do not cram it all into one little corner. So once you're finished with these steps, you guys are going to start copying that into your lab notebook. If you want rulers, I have some rulers up here. If you would like a ruler,
already got mine on
if you're paranoid about writing things out and you want it, or drawing it out and you want it done perfectly, obviously I don't care about writing things perfectly because my lines go all over. They're right in front of Allie.
So write down materials.
No, you're drawing this, and then you're going to go on to the data table.
This is too hard. Oh my goodness. 3, 1, 2, 3. I have to do it all. I'm so good. 2, 3, 4.
First grader, dude.
They're right up front where Lainey is standing right now.
One, two, three, four, five, six, seven, eight,
Wait, are we showing this?
Uh-huh.
yeah, this is one. Extreme. Oh, oh, okay. Now my box so big. Come with me, buddy. Okay.
It's the only time that you can have something about it.
You don't use a pencil on a random though. Do. Go on. It's still work. It doesn't. She's gonna take off one. We got like 3 days. 1, 2, 3, 4, it's hard. You have a ruler. I can't do it. Everybody did here.
Sure, you can do it.
I need
And then that's motivation.
I need more.
Now.
No, you haven't. You're supposed to now be typing this into your lab notebook.
With the numbers.
What's your opinion on call-up area?
It's a great thing.
It's great. What it is, babe.
No.
I agree that no call-up is 7. On call-up. Everyone on call-up.
The game?
Oh my god.
Yeah, you're on call-up.
Well, I'm wait. Very big. What?
Is it big enough this bush?
Holy.
Yeah.
You know
I did it. I think it's fine.
Ty, what kind of car do you think Parrish should get?
No.
You know what I think you should get?
No, don't even say it.
Because I think you should get.
Don't, he's gonna say Jeep truck.
I think you should Jeep truck.
Why?
So bad. No, Perry, it'd be so funny to see you call this one every day in your Jeep truck.
I'm not sure. I get the Jeep. They're good, and then they brought the truck.
It's so funny. The waste of time.
That's why you say Jeep
Sure, you want to talk.
Kidding, no one has. Again. Jesus, swear. Oh yeah. You look like Ty.
I look like Ty. I look like Ty.
No, you look like Boba. Me?
Are we done?
No.
Yes, you do.
Now you are.
All right. Well, we're gonna be done for now. You guys will just have to finish it at home so we can get started on the rest. Okay?
I finished.
Believe me.
Wait, after we finish this, do we have anything to?
No. No. Okay. So go ahead. If you haven't finished drawing it in, you can do that at home. And go to page 8 of the packet. And so we're going to be writing the products of double replacement reactions, and we're going to predict whether they will precipitate or not. So first one, sodium's going to switch places with sodium. Are we going to have any kind of reaction here?
No.
No, so we're going to write N, V, R.
Not very rad.
No visible reaction. Okay, Perry, did you have a question?
No,
Okay. Number 2. The sodium and the copper are going to switch places. The sodium is going to bond, or it could pair, with the sulfate, but we know what about sodium? It always is aqueous. All right, copper 2 hydroxide, though, could be different. What do we know about hydroxides?
They're only soluble with the group 1A ions, ammonium, calcium, and
Right. So, is copper 2 hydroxide going to be soluble or insoluble? It's going to precipitate. It's going to be insoluble. The third one, we've got 2 sodiums. No visible reaction. The fourth one, we have sodium and ammonium. What do we know about ammonium?
Soluble.
He's always soluble. So guess what? No visible reaction.
How is it no?
Because the sodium is always going to be, when he bonds with the chlorine, that's going to be soluble, and ammonium is always soluble. So when he bonds with the OH, he's still going to be soluble.
Oh, right. Okay.
So it's no visible reaction even if they are both soluble or both insoluble?
It's a no visible reaction. If you want to write the whole thing out, you can. But I'm trying to give us a little head start here. Okay, some of them we have to write out because we don't know. But some of these we can just look at it. All right, here we have sodium switching with hydrogen. Hydrogen, while he's not a 1A, will react like the 1A metals. So sodium would bond with chlorine, hydrogen bond with hydroxide. What's HOH? H2O. So are we going to have a reaction there?
No.
Technically, we have a reaction, but you won't see it because you're just making water. So you can write NVR. All right, the next one. Sodium is going to bond with the nitrate. And lead will bond with the hydroxide. And lead hydroxide, we're going to have to look up. So look on your periodic table, solubility chart. Is hydroxide going to be soluble or insoluble with lead? Insoluble, so we'll put an S for solid. The next one, sodium. What do we know about sodium ion or sodium compounds?
It's always soluble.
It's always soluble. How about potassium? Always soluble. Guess what?
No visible.
No visible reaction.
So if it's both soluble, we just say no visible reaction.
Uh-huh. If they're going to be soluble no matter what. All right, the next guy, sodium is going to bond with nitrate. And silver is going to bond with the hydroxide. Is that silver hydroxide going to be soluble or insoluble? Do you guys agree? Insoluble?
Insoluble.
Okay. The next one we have sodium and potassium. What do we know about those guys? NR. The next one, the sodium, is going to bond with chlorine, our old friend. We see sodium chloride a lot in this lab. And it's going to leave the iron to bond with the hydroxide. Is hydroxide going to be soluble with iron? No. So it is insoluble. What's your question?
No, I'm just trying to like understand.
What's your question?
So like, did a reaction happen because sodium's always soluble and the Fe with the chlorine isn't?
The iron chloride is soluble. They're both dissolved. When they mix, the attraction between iron and hydroxide is stronger than the pull of water. So the iron hydroxide will precipitate.
Okay.
Does that make sense?
Yeah.
No?
Yeah, it's fine.
Okay. All right, the next one, iron will bond with phosphate. And we'll get sodium chloride. We know sodium chloride's soluble, right? If there's anything you guys have learned today so far, hopefully it's that sodium chloride's soluble. What about the iron 3 phosphate? If we find phosphates is not soluble, that's what she said, insoluble. Yes. So we're going to precipitate. Iron 3 chloride plus copper 2 sulfate, we're going to get iron 3 sulfate. And copper chloride, copper 2 chloride. So, iron 3 sulfate. Let's look up sulfates. Sulfates are all soluble except for calcium, strontium, barium, lead, mercury, and silver. Does iron fall in this category?
No.
No, so therefore this guy will be
Soluble.
soluble, AQ. How about copper 2 chloride? Insoluble. Let's look. Chlorides are soluble with everything but silver, lead, and mercury. Is copper, silver, lead, or mercury? No, so he's also aqueous. So guess what? That's actually an NVR.
Wait, that's
Because they both end as aqueous.
Oh.
If both of them would be insoluble, is that NBR too?
No, they won't both be insoluble. I don't think I've ever had one that was that way. If I do this, reset this, and I put in sodium chloride and sodium sulfate, if we come back and look at this later, those are all still going to be bouncing around in there. So we'll come back and look at that later and see if that's true. All right, iron chloride and sodium carbonate. We're going to have iron 3 carbonate and sodium chloride. We know sodium chloride is soluble. What do you think about iron 3 carbonate? Say it again.
Insoluble.
Very good.
wait. Alright, can you go back?
We're wasting time. All right, number 4. Yes.
Thank you, Russia.
No, it's 10 minutes till. Yes, you may go to the bathroom. Have I not said this?
We have to write all
No,
these
no,
down.
oh my.
I just keep going.
You may.
I was like not.
Okay, iron chloride plus ammonium chloride. Are they? Yes, you can go. You need to do a pass. I don't have the iPad out, so just go. No one cares. I'm going to have to make another announcement that you do not need to ask me if you have to go to the bathroom. You're a young adult. You can figure it out.
Question, are we gonna have to write all these in our lab notebook?
Not in your lab notebook, in the notes. Because I'm trying to save you some steps. So this is half the writing. Because you're only writing the products. Okay, will this reaction occur? So we'll have NVR for that. How about 15? Will it occur?
No.
So it's NVR. Because they're both chlorines. So when iron and hydrogen switch places, it's still going to be iron chloride and hydrogen chloride. The next one, iron 3 chloride will bond with iron 3 nitrate, or bond with nitrate. Iron 3 nitrate. And lead will bond with chlorine.
Is that nitrate 3 or 2?
It's a 3.
Nitrate 3.
So we got to
Okay.
we got the it was NBR on 14.
Iron nitrate, is that going to be soluble or insoluble? Soluble. Lead chloride. Look at your chloride on your periodic table, on your solubility chart. What are the 3 things that react with chlorine?
Lead.
Silver.
Silver, lead, and mercury. So he's going to be a precipitate.
So soluble.
The next one, iron 3 chromate. Iron 3 chloride is going to react with
3
chromate.
or 2? Oh.
The name of the ion is iron 3.
Oh, okay.
He has a +3 charge. Chromate has a -2 charge, so we have to make them happy. All right. And potassium is going to be bond with the chlorine. So look at your solubility charts. Chromates, find chromate. Is that going to be soluble or insoluble?
Maybe
Insoluble.
Insoluble. All right, number 18. Iron 3 nitrate will form, and silver chloride. The nitrate will be aqueous, right? So what about the chlorine? Silver chloride.
Insoluble.
It's insoluble, so it is going to precipitate. Dakota, are you wondering why is iron nitrate soluble? Is that what you're wondering?
Yeah, it's fine.
But look,
I'll figure it out.
that's all right. If you look back here, it's a nitrate, and all nitrates are soluble.
Yeah.
You just have to be able to go back and forth.
Like I can't.
No, I understand that, but if I go slower, then we
No,
aren't
I
going to get done.
understand. I'm just trying to figure out how.
Okay. Next one, iron chloride iron is gonna bond with iodide, and potassium is gonna bond with chlorine. What do we know about potassiums?
they're always soluble.
They're always soluble. Iron iodide, iron 3 iodide. What do you think about that?
I think it will soluble.
It is soluble because iodate acts like a chloride. So if it was lead iodide, mercury iodide, or silver iodide, it would precipitate. So this is another NVR. The next one, we have potassium and sodium. They're going to switch places. NVR. Why? Because potassium's always soluble. So when potassium bonds with the phosphate, it's still going to be soluble. When the sodium bonds with the iodide, it's still going to be soluble.
So if they're both soluble.
There's no reaction. You won't see anything. It'll be like this, where they're all still bouncing around in there. All right, next one, potassium sulfate and copper 2 iodide. What do we know about potassiums? They're always soluble. Now look at the iodide. It's in the chloride column. Is copper, lead, silver, or mercury?
No.
No. So therefore, this guy is aqueous also. So this is another NVR.
So if they both end in aqueous, it's NVR.
22 is NVR.
22 is NVR because you've got potassium and sodium. So you don't even need to write it out. 23, potassium and ammonium are switching places. Those are both always soluble. So NVR. The light bulb just went on.
So if everything in the equation is soluble,
There's no reaction.
so you just need to know what is soluble.
Yeah.
Anything with potassium is going to be NVR.
Anything with potassium is soluble, huh?
None of them have a reaction though?
No, they're just all ions bouncing around in there. And when the water evaporates, you'll have a mixture of both of those chemicals. Okay, potassium iodide and hydrochloric acid. If we switch places, we're going to have hydrogen iodide and potassium chloride. So this is another NVR. Yes.
So like if the things that you're switching, like in the replacement, are both soluble to begin with, it's gonna be NVR.
Well, just the cations.
Yeah.
Those are both always soluble.
Oh.
So they're going to combine with the other thing, and they're still going to be soluble.
Yeah.
All right, number 25. Potassium is going to bond with nitrate, and lead is going to bond with the iodide. Lead 2 iodide. Iodide's related to chlorine. What do we know about lead?
It only reacts. It's insoluble.
It's insoluble. 26, they're both potassiums. What's going to happen? Nothing. 27, it's going to be potassium nitrate and silver iodide.
Where my class is. Like, then there should be a 7th hour.
Oh.
I don't.
It's not soluble.
Silver iodide is like silver chloride. It is insoluble. Here we're going to have silver nitrate and sodium switch places. So we're going to get silver phosphate and sodium nitrate. Sodium nitrate will be aqueous. What about silver phosphate?
Where's P3 on the end of NA?
Well, it's supposed to be a little 3. It didn't translate well.
So when we add the little to
It's not soluble, right?
What's sodium's charge?
Okay.
What's sodium's charge? What is sodium's charge? Not -3.
Plus 1.
It's +1. All right, and there are 3 of them. What's the charge on phosphate?
That's -3.
That is -3. So we need 3 sodiums to balance out the phosphate. But over here, sodium's a +1 still. Nitrate's a -1. Do we need 3 sodiums? It is not balanced. That is true. If we balanced it, it would take a lot longer, and you don't want me to do that. The next one, silver sulfate.
Is silver phosphate aqueous?
It is going to form a precipitate. Copper 2 nitrate. Is aqueous. Silver sulfate is slightly soluble, so you may have a precipitate here or you may have NVR. We don't know. All right, number 30. Well, then pack up. Number 30, silver is going to bond with the carbonate and sodium sulfate, or nitrate. And silver carbonate will be insoluble.
Thank you.
You're welcome.
No.
I did try it.
I'll figure it out.
If I get 7. He basically said, I don't want to like Katie anymore, and then he shows up the next day and he's right next to me.
Miss Dennis saw me like not here. I can't do it.
So your homework is to finish those.
Finish.
Those.
You didn't take this home.
No, you don't need to take it home. See you later. Oh, I have something for you.
No, in like 2014, I wrote about getting my yellow belt in Taekwondo.
Nice.
And I said, today was February.
Thank you.
I thought you might find that interesting. Do you like my bulletin board?
Yeah, I took a picture of it and sent it to my friends back in Wyoming.
Oh, good.
It said, my chemistry teacher puts chemists and other scientists that follow a specific category every month, and I told them how February was Black History Month.
I'm too tired. That's right.
And then March was women, and I told them that, so yeah.
Honestly, I should do the same, but then we have
Cool.
testing next week.
Miss Bush,
Yes.
can I take the test Monday during advisory, or do you need me to take it right now?
You know, you
I
can do
would
whatever you
seriously
want.
take it now though, because of your concussion and we're gonna be testing all week. Next week. We'll be taking a math test Monday.
I already got a headache because I had digital design.
We're gonna be taking a math test Monday.
I'm
gonna get a
save
bigger
this
headache.
much. Can I take it next week?
Is there? Yes. If there's.
Because I need to study. I need to study for it. and-
So you had everything filled.
Yeah, except for like 10, I think. I didn't finish.
Oh yeah. Go ahead and finish 9 and 10.
Miss Bush, can I see how much I have left real quick? I want to see like what I have to do. I need to do the barometer and then I need to do the T and 10.
Yeah.
What?
You want me to put my phone up by the board?
No, I'm not gonna. I'll trust you.
Yeah, Dakota.
But yes, Perry, if you really want to wait and take it on Monday, that's fine. I'll let you do that.
That's what I'm
But
doing.
you're so close. So you need to pass Monday. Gavin needs a pass Monday.
Well, I already am doing a pass to take a math test on Monday.
Okay, so when are you gonna take this then? After
I-
school?
I can ask my mom if after school on Monday.
All right,
I
sounds
can stay.
perfect.
Yeah, I'll wait until Monday for advisory.
But if it turns out that I finish my math test with the time, I could just swing by her classroom and ask.
Who's your math person?
Miss Dennis.
Okay. Well, we'll
But-
get it done.
Yeah.
I just can't pass them back till everybody's got them done. So.
I'll come Monday advisory for sure.
Okay.
I'll plan on Monday after school.
Okay.
Thanks, Miss Bush.
Yeah.
Have a good day and a good weekend.
You too.
Okay.